Hello students, welcome to the module number 5. Again, the other materials and material selection we are going to discussing now, and furthermore processing of the plastics we are going to discuss now. The first one is compression molding and resin transfer molding. Okay, so what is going to be compression molding? So already you know that in the previous chapter also you understood the compression molding is one of the important and very simple technique of process. So that is a closed molded process. It is like a closed molded process in which pre-calculated amount of thermoset plastics and material along with the additives are placed in the lower half of the heated mold. So here the lower half of the heated mode is going to be taken place for the additives are going to be placed, and immediately upper half of the mold moves downwards. The direction it is shown here, the upward, this will be moving in downward direction. What happened, it is a press that added material on that material or compressing this heated material and forcing it to fill in the mold cavity. So a hydraulic ram is often utilized to produce sufficient force during this molding process. The heat and pressure are maintained until it material becomes cured. So this mold is opened and the part is removed by this means of ejector pin. So these thermoset materials are cured by irreversible chemical reactions under heat and pressure. So the result in this, the reaction is going to be highly cross-linked molecular structure that gives the material to retain its property at elevated temperatures. So this process is going to be used for making parts like electrical components and fitting panels and housing container caps, or even for the dishes and body panels, and need to hold the for automobile components. So these are all the some applications for the compression molding. So let us begin. We can have a look at industrial compression molding, how it is going to be taken process. So by seeing this video to understand. Okay.
Construction details of compression molding machine. A typical compression molding machine has following parts: upper mold, bottom mold, control unit, actuator. The upper mold can slide up and down by the actuator. Raw plastic. The lower mold is fixed. The upper and lower mold join together and form the mold cavity. The control unit monitors the process and control it. Working of compression molding machine. In this, a pre-measured quantity of plastic in the form of charge is placed in the bottom mold and heated. Then, the actuator moves the upper mold downward and forces the charge into the mold cavity and returns back. Molded product.
I hope you understood by seeing this video for a clear idea about compression molding. Let, Next slide is going to discuss about resin transfer molding. Okay, so this resin transfer molding is consists of various components, and this figure I took from the source from CSIR NAL, so to understand better concept of resin transfer molding. Okay, usually it consists of uh, some of the major parts like sprue will be there, heater will be there, and plunger will be there. Okay, so even for this material, generally we have low pressure there is a mold process designed to overcome the disadvantages of compression molding. So where in compression the charge takes place directly into the mold cavity, but in operation of this resin transfer molding, the cavity is initially given a gel coat. Okay, the cavity the gel coat, and the mold is going to be closed. So a pre-calculated amount of thermoset plastic mixed with this desired additives and is placed at the transfer pot. Okay, so here you can see this the figure. Okay, so the plastic charge is going to be heated in the pot and by means of heating elements, due to which it is going to be softened and reach semi-molten metal state. And this molten state, and this plunger mounted on the top plate, and it moves downwards by controlling valve, and the pressing of the plastic charge and forcing of transferring into a mold cavity through this screw. The mold is equipped with the heating system and provides curing of the polymer composition. So this mold is going to open part is removed from this by means of any of the ejector film. So here we can see the detail, and once if you understand the video lecture, you can able to see the process in detail. Okay, so let us we have a look at for this resin transfer molding.
Involves injecting a resin through reinforcement placed in more substantial rigid tooling manufactured from composites or metal. RTM can offer distinct advantages, particularly if temperature-controlled tooling is used. Increased productivity through the use of higher injection pressures and heated molds. Improved quality. Improved product consistency due to better process control. Improved dimensional tolerances. The mold is gel-coated by either hand or spray application. Because of the use of heated tooling, the reinforcement can be laid onto the gel coat far quicker than at ambient temperatures. A surfacing veil or fleece material, as shown here, can be used to reduce the glass print-through. Once again, deformable stitched mats, such as Rovicor, offer distinct advantages in glass loading. Core materials may be incorporated, but their dimensional accuracy is critical to the success of RTM. The mold is closed and clamped using bolts, toggle clamps, or sometimes a press. Liquid heating is used to ensure consistent temperatures. 40 degrees C is a typical mold temperature. The mold is vented at the point of final fill. Resin is injected from a central point at typical injection pressures of between 2 and 4 bar. Machine options such as the mold pressure guard or MPG ensure that the injection is controlled and that the molds are not overpressurized. It will be expected to see a small amount of resin at the vents to ensure that the mold is full. Once injection has been completed, the injection head is removed, a stopper is placed in the injection hole, and the machine flushed with solvent. Once the resin has cured, the mold is opened and lifted to allow demolding. The heated tooling allows quicker curing of the resin, and so quicker cycle times are achievable when compared with ambient temperature processes. RTM can use metal molds such as nickel shell, aluminium, or steel for maximum durability and improved surface finish. However, the principles of the mold design and the process remain the same. Further automation can be achieved using auto-screw technology. This valve is built into the mold and allows simple connection of the injection machine. At the end of injection, the auto-screw automatically flushes the machine with solvent, and then the machine can be easily disconnected. Once the part has cured, then it can be demolded, leaving the mold ready for the next component. The use of RTM can be limited by
the higher cost of tooling, the cost of an injection machine, but also by the gel time required for mold filling, which limits productivity in very high volume applications. However, RTM is now a proven technology for fast and efficient production of GRP components.
So I hope you understood all this process for resin transfer molding by seeing this video. So let us will discuss some of the topics in the next video lectures. Thank you.